Thank you, Zoe. Welcome everyone for joining us into this webinar today, where we are going to go into a little bit of details of moving your conceptual and preliminary design from Infraworks into the detailed design within Autodesk Civil 3D. So, as Zoe has said, I'm the applications engineer working with Idea Technologies, also with the World's View, with a focus on the civil and structural bit. I specialize on the infrastructure for BIM, in the BIM for infrastructure. In terms of experience, I have more than 5 years experience in civil engineering, running from different projects, especially here in Kenya. So we'll talk more about this as the presentation starts shortly. So I will hand over back to Zoe for some quick poll questions. Zoe?
Yes, Elijah, I will be launching the poll questions for our participants. If you could please participate in the polls, that would be greatly appreciated. Thank you very much. 70% of our participants have participated in the poll questions. I will share the results just to give an indication of the results of the poll. So about 71% of our participants are beginners, and 7% have used it in 1 or 2 projects, and 7% have said that they use it in all of the road design processes, and 29% have not used the Infraworks Civil 3D before. In the second question that we had is, which of the following consumers most of your time in the road project design process? 50% are establishing existing conditions, 57% are concept and preliminary road design, and 50% are moving from concept and preliminary design to detailed design. And the last one is 50% of our participants are detailed design and documentation. So thank you very much for participating in our polls. Elijah, over to you. Elijah, I'm not too sure if you are on mute, but I'm unable to hear you.
Sorry. I was on mute.
Repeat what you said in the previous slide. I'm not too sure if the participants have heard.
Great. So this is my today's objective or agenda that I intend to cover. So I'm saying that The first 10 minutes, like a quarter of my presentation, will be using PowerPoint to just illustrate an overview of the concept and design, and also some level of understanding of what geometric design is in terms of horizontal and vertical alignment design criteria. Then after that, I will do a live demonstration showing how each of those tasks in terms of doing horizontal alignment design and vertical alignment design between Civil 3D and Infraworks. So that's why we develop the concept in Infraworks, do preliminary design also in Infraworks. Then after that, we'll move our selected preliminary design alternative into Civil 3D, where we'll be able to perform our detailed design in terms of evaluating the various design criteria that has been met or violated, and also be able to generate our related earthwork volumes and documentation. So just to give us first an understanding, I'll assume most of us are either civil engineering or has some background on what geometric and geometric, that is vertical and horizontal design, is in highways and engineering. So first, the basic design criteria for design, for a geometric design or a road design, is usually the functional classification. So before one decides on what road to design, they first need to know what's going to be the function of the road. And function of the road mainly is to provide access to people and also to provide mobility. Where when we talk about access and mobility, is just in terms of how accessible should it be to the surrounding roads or the adjacent road which links up to it, and how easy will it be for an individual or a vehicle user to move from one point to another. So we find that in defining those parameters when designing a particular road corridor, access and mobility are inversely related, in that if you want to provide highly accessible road, it means that mobility will reduce. Is that very many access or intersectional junctions getting into that particular road corridor you are designing lowers the ease with which people move from one point to another. And the same also, if you want to provide high mobility, the accesses must be limited. So those are some of the first two key considerations that must be taken into account when you want to start designing a road. And in many cases, those will be defined by different road design standards, which are varying from one country to another. So in terms of hierarchical highway function classification, again, this also varies where different roads are classified depending on the regions and on countries. So where internationally, most internationally recognized are the principal arterial or freeways, like here locally in Kenya, we classify them as class A roads. But basically, they are meant to provide very high mobility with limited access. And therefore, it means that there is high design speed, sometimes even more than 100 kilometers per hour. Then we move to the next class, which is the minor arterial or class B, which interconnects the principal arterials or freeways and with moderate mobility or limited access. Then after that, there's the collector or class C going down up to class D, which basically now provides more access than mobility. So those are some of the classification that you should have in mind, and we look at them, how you can be able to use both Civil 3D and Infraworks to define each of those functional classification. So each of the function will be having their own defined design speed, and of which we'll be able to see that the design speed is like the main determinant in terms of the various geometric parameters that we are going to look at, which have also been defined in the different design standards that are used in different parts of the country. And again, so what the software will do, will be able to, it translates for us each of these classification with their corresponding design speeds and geometric requirements into some very simple parameters that you can easily use when doing our detailed design in Civil 3D. So again, just as an overview, in terms of, again, of a geometric consideration, these are some of the factors or parameters that the designer need to put in place. So like when you're designing for your geometry, that's both vertical and horizontal alignment, you should be able to provide for adequate sight distance. That is, if a vehicle is approaching from one end and negotiating a particular bend, they should be able to have adequate stopping and passing sight distance, both of which are defined by the curve radius, the tangents that you have, and also the grade of that particular terrain that you are designing on. Also, traffic volumes in terms of the capacity that the road can carry, the speed, the turning radius, and the intersections that you have. And most important is also the topography on which you design. Where I find that the topography may vary from a flat, rolling to mountainous terrain. And each of these, based on the different design standard that you will use to design, will specify the minimum required grades. That is the grade in, the grade out, because each of them will also have an impact in terms of the design speed that can be achieved at particular section of that particular road that you are designing. So those are some of the key parameters, again, that you need to consider to be able to provide safety and comfort for that particular road that you are designing. So again, just as an overview in terms of horizontal alignment, we are basically looking at the straights and tangents, straights or tangents, the circular curves, transition curves or spiral curves, plus super elevation, where we know that super elevation basically allows the vehicle to counteract the effect of a centrifugal force when someone is negotiating a particular bend along the road. So sometimes coming up with these parameters and clearly defining them by ensuring that each of the design criteria is not violated manually or using AutoCAD sometimes becomes very, very difficult. And that's why we're going to look at each of them in Civil 3D, where based on the specific code of practice that you use, for example, you can see that that for a circular curve, the minimum curve radius is defined by the equation, as you can see there, which is basically the squared of the design speed over 127 plus, in brackets, the effect of the centrifugal force plus the super elevation itself. So defining these parameters manually or trying to calculate them manually while drawing in AutoCAD sometimes can consume your time as an engineer, where you need to make several references to the different design standards that you want to use to ensure that you meet the criteria. So that's why I'm going to look at them, how Civil 3D and Infraworks already has each of those parameters clearly defined, so that you're just supposed to maybe focus on the simplest requirement, that is the design speed, which we find that controls like each of those parameter that has been defined. So like if you ever look at this for the super elevation, so you see that different super elevation rates will affect the minimum design speed plus the corresponding design curve radius at each section of the road that you are considering. And this also varies based on whether you are looking at an urban road or a rural road, and also whether the road hierarchical classification also is maybe class A, class B, or class C, or maybe based on classification in terms of freeway or arterial or collector road. Like when I see that if you talk about applying a rate of super elevation at 4%, we find that if you are to achieve a 120 km/h design speed, you require a very large minimum curve radius if it's a circular curve going up to about 630. But if you are to just look at maybe a lower functional road class, you can maybe, for not defining a design speed of 50 km/h, you find that the radius reduces. So that's basically some of the parameters, again, you need to consider before you move on to starting to model your road on the different platform that you're going to see today. So not only are we going to consider the horizontal alignment, we're also still considering the vertical alignment, which is basically the longitudinal profile of the road. So in terms of the straights, the grades, the vertical curves, and the transitions, which allows one to transit from the grade, that's the tangent, to the vertical curve, or from one vertical curve to another vertical curve, that is either sag or the crest. So again, that diagram there just illustrates what we are talking about in terms of vertical alignment. So again, the main factor to consider again is still the radius of the vertical curve, which is largely determined by the grades again, that's the grade in or grade out. Plus also in terms of consideration, you still need to consider the lengths or the distances for passing and stopping sites. So that if someone is approaching a particular mountainous area, going even to the smaller details in terms of maybe the headlight said that when he's approaching a particular sag, the headlight should still be able to project further to allow him to see an oncoming vehicle, maybe if that particular guy is driving at night. So each of those are the parameters that we find that if you are to go manual or be able to establish them from the defined design standards based on your location or region, achieving them precisely with the required accuracy as a designer sometimes may be very, very difficult. So I will illustrate to you how you can access each of those specific code of practice within Stable 3D and even customize them to localize them to meet your local design condition within Stable 3D. So this is what I'm saying, that, for example, if you are approaching a particular curve within a vertical alignment, again, the design speed will directly be determined by the grade that you are achieving on that particular slope, and correspondingly with also the sight distances, that's both passing and stopping. The same also happens in terms of the SAG, where each of these has been simplified to what we refer to as the K values, which now helps you as a designer to use very simplified equations and parameters as opposed to the equations of SSD that sometimes are very, very long and confusing. So these values have been simplified into K values so that you just need to know that if I'm using a design speed of 30 kilometers per hour and my grade in and grade out are these specific values, what do I require in terms of ensuring that all those required parameters are met? So you just talk it in terms of the K values required for each of those. So that's just basically an overview if maybe it's the first time you're hearing about geometric design for road. So there's still more theoretical equations, tables, and analysis which are performed based on the different code of practice that you use. So like the most commonly used code of practice could be maybe the AASHTO, the design manual for roads and bridges from UK. Like here in Kenya, we have our own local design standard. And most of these equations that you have been seeing here and the tables were just extracts from our local design standard. So each of them, like you find that most of the commonly used design standards were just some customizations from AASHTO or the design manual for roads and bridges from UK or the French design standards and the Australian. So when we talk about now going into the Stable 3D, it's basically a tool which now helps you into simplifying that process of defining those design criteria and parameters for a road geometry in a very simple way, where all of those tables, all those equations have been simplified, so that if I want to do a transition from maybe a vertical circular curve or vertical parabolic curve, what exactly are the minimum curve radius, curve length do I require based on the specific design speed that you want to achieve for a geometry? But you find that, again, just starting it from Stable 3D from scratch sometimes may be challenging or may be time consuming. So that's why we needed to bring Infraworks in the picture, because Infraworks provides you with a very easy and simple to use tools in terms of laying out your concept. And as you laying them out, you'll be able to also ensure that the concept being laid out meets some of the minimum design requirement based on that specific design standard that you are using. So as of course, as you know that you can't design this geometry anywhere or out of nothing, the first thing you usually require is to establish that existing condition in terms of the topography, in terms of the existing buildings, the existing roads, existing utilities within that particular project area that the new project is going to be done. So you still can do that within Infraworks by being able to build up from different data sources, like maybe the photogrammetry, the point clouds, the land XML, and all those different file formats. You can use them to build up your site in Infraworks, then develop your context, do the concept, and do the preliminary design, as I will illustrate. Then after that, you switch your preliminary concept into Stable 3D for the detailed design bit, considering each of those parameters that I've just highlighted on part of the geometric design. So basically Infraworks, that's how it looks like in Infraworks as compared to if you have worked with Stable 3D, which is more similar with AutoCAD in the way it presents its content. So one big advantage, again, I like with Infraworks is the fact that you can be able to do different design proposals. So meaning that if you are tasked by your client to be able to generate a preliminary design, before you come up with a final preliminary design to present to them, you can at least be able to generate different design alternatives, evaluate them, and after the evaluation, choose the most feasible design alternative to present to the client for maybe for their review before they finally come to the conclusion whether to adopt it or not. So basically that's as an overview, and that ends the part of my presentation. So I'll take the next seconds to switch to the Infraworks to just illustrate some level of concept that I will already come up with. So I will not illustrate the process of building and creating your infrastructure model that you can work with within Infraworks. So I'll assume that at this particular stage, you have done different design alternatives, you have evaluated each of them, and you are in the process of now moving in from the concept part to the preliminary part, where you're just basically focusing on the small details in terms of what are now the required design speed, what are the functions of the road, what are maybe the earthwork volumes that you're looking at in terms of cut and fill. So I've already got this model here for an existing project. So it has inbuilt existing roads and other infrastructure component. As you can see that based on the GIS data that I could access, I could even be able to bring up the underground pipe networks, but you can even build it further by showing more detailed information in terms of what exists in the context of that particular project area. So as I was saying, with Infraworks, you can be able to generate different design alternatives and proposals based on the scope that was defined by the client that you want to deliver the project to. So like, I'll just switch to my master. So master basically is the project site condition as is before you add anything into it. So basically the way you are building it from scratch by adding different surveying and the GIS information. Then after that, you can be able to start building it up. So like, maybe I'll just give us maybe an idea of what I intend to do. So for example, this is the project area. Our main aim is, as of now, the town is mainly centered in this area that, as you can see on your screen, but there is very big developments happening on the other side of the town here. So a lot of big building projects are coming up, commercial activities are really picking up on this other area. So the city or the municipal has tasked you as the consultant to come up with a concept and a preliminary design to present to them and choose the one which will be the most feasible design alternatives. So basically, some of the consideration is in terms of maybe the cost, where you need to evaluate an alternative which will be most feasible in terms of cost, with minimum maybe land acquisition, and also minimum disruption in terms of the existing traffic and what have you. So with that, I came up with two proposals in this particular interface, where I came up with connecting the northern part of this city and the southern part using two different accesses. So my first access is basically to connect it to this existing roundabout, so that I should follow up this existing road corridor, if you can see where my mouse is, and link it up to the northern part to connect to the new development area. So that I created it in a proposal I was calling the East Access. So I'm switching to that East Access. So it basically shows that I was laying out a road corridor to basically show how I can link it up. And you can clearly see that with that, it means that the area that I'm proposing, you can see that towards the southern part, it is likely to result into very heavy land acquisition, because this area is already heavily built. And even if we try to minimize our road corridor, maybe like using a right of way of maybe 40, which I will easily show how we can do that, you can be able to see that it's going to be a highly functional road with a very high level of mobility. You can see modeling for a road corridor of 40 meters wide will result into many of these guys being relocated. And a lot of disruption will also happen, because the process of relocating these guys and acquiring this piece of land will also be very, very expensive. So that could be maybe one of the possible considerations if you are tasked by linking up the two parts of this city with an infrastructure project. Alternatively, you can still link it up by creating another one which directly access this particular point, which I've selected. If you can see the area which is with a gizmo, you can alternatively produce that which is running directly straight into the other side. as an alternative. So the aim is, for a real project, you need to do a number of evaluations, not only just in terms of maybe operation, but also things like maybe environmental consideration. Are there some conservation areas that will be affected by the project? So my most feasible alternative from a number of considerations I made, I found it to be the one which was running on the western part. So I'm switching to that new design alternative. So I developed a new alternative running from the western part, linking up the existing road on the roundabout on the western part here. So again, this was an existing roundabout here. And I also able to establish for it a right of way, which was still also 40 meters wide, showing how it's going to run. So the main advantage which I realized with this one is that if I run it through this open land, the cost of acquiring that piece will be very, very lower compared to the one which I was trying to establish on this other side, which was already heavily built up. So again, with Infraworks, you can be able to perform each of those alternatives and evaluate each of them in terms of all the design requirements and the parameters based on the scope that was defined by the client when you're taking up the project. So I've come up with a design, which I basically started by laying it out from the concept. So just to illustrate the process of doing a concept, I will just say that this is the concept I want to do. For example, I'll pick up the road. So I start by laying that road from scratch, the same way you would model it in any other, maybe like on a piece of paper or in AutoCAD. But advantage with Infraworks is that it already has inbuilt different types of roads, whether you want to do a dual carriageway, single carriageway, including different road furniture that you'd want to form part of your design model. So like if I wanted to do it directly by linking it directly from the northern part going back to the south, I just click on the road. So I'll just use the default one there and click and draw directly. So this basically is a concept road, trying to show a way of doing your concept design with Infraworks. So as you can see, once I do it, you can see it automatically gives me that proposed road corridor. It's a 3D line sketch of what I intend to have on that particular area. And you can see automatically, it also gives me an overview of basically what kind of maybe elevations will I be looking at with respect to the existing ground. So if I wanted to now start having more control in terms of the design criteria, functional classification of that particular road I'm doing, you just need to convert it into what we call a component road. So component road is basically a type of road classification in Infraworks, which now allows you to have more control and start specifying various design criteria and parameters that you want to use for that particular road. So basically in terms of the curves, the tangents, the design speeds, and more so the classification of the road. So you can see right now I've converted into that particular component road. And you can check on my right-hand side of the screen under attributes, there's the road. I can give my road a name. So maybe I can call it's going to be M01 road. And the function automatically now start appearing there. So if I want it freeway, arterial, collector, or local road, I just choose for each of them. And choosing for each of them allows me to easily switch from lower design speed to high design speed. As I said, is the value which will determine exactly what are the minimum curve radius that you require. So like if I say it's going to be a freeway, I can easily now adjust the design speed even to up to 110. And immediately I adjust that. If I now check on my curves, for example, you can see my curve still meets that particular value for each of them. So like this curve radius here is 450. So as you can see, I say that the curve radius may vary based on the design criteria that you're using. So like in this case, not depicting what I wanted to show. So I'll just switch up to the model that I already modeled here. So you can see for this my proposed concept, which I've converted into a preliminary design, because you can now see I have very well laid out roundabout in terms of the specific design that the roundabout follows. So like my roundabout follows the TD16/7, and it's a compact roundabout giving me a minimum design speed of 40 miles per hour. In terms of the geometry for the road itself. If I click on the road, you'll be able to see it tells me the exact PI for the curve that allows me to negotiate this curved part. And as of now, I'm using an arterial road with a design speed of 80 kilometers per hour. And you can see, based on the design criteria which I'm using, which in this case is the DMRB, as you can also see still under the design speed. The design standard is the Design Manual for Roads and Bridges metric, that is UK. It tells me that for this particular curve which I've provided, it is 157. And at design speed of 80 kilometers per hour, that particular curve violates that design criteria. And you can see under the curve geometry, still on my right-hand side, the curve geometry, it is highlighted with a yellow color, or there's a warning already notifying you that though you have provided this curve with a curve radius of 157, but based on the design speed, the design criteria that you have specified, and the design speed that you want to achieve at that particular section of the road, the curve radius is violated. So you can see it tells me that the radius violates roadway design standard. So based on that design standard, the supported values for this size of the curve should vary from 226 up to about 314. So mean that as I'm laying out this geometry right now here, based on the design speed that I've selected, the value must meet the design criteria based on the specification for that geometry point. But you realize that if I were to lower the design speed, the value may meet that criteria, because remember I said that the higher the design speed, the higher the length of your curve radius, the slower the grade that you require. So what I may need to do, just to illustrate again, I can easily lower this design speed to 60, sorry, from 80. And you'll see that if I lower it, the value, the indication or the warning sign there by color yellow will disappear. But that basically still means that as long as that particular curve radius is not violated, it will now not be a warning. But even if I make the design speed to something which still makes it to be violated, it will still remain as a warning. So like if let's say I wanted to make it 70 as the design speed, you will be able to see that the violation may still be maintained, just to illustrate that the value, though you have lowered the design speed, the minimum curve radius required there still is greater than what you are providing. Alternatively, you can adjust the point of intersection or the point of tangency and the point of curvature. So like this is my point of tangency. I can easily increase it, adjust its position to widen the size of my curve. So you have all those alternatives. So again, that's what Civil 3D will now allow us to do, because within Civil 3D, we can specify different design speeds for different sections of the road. But with Infraworks, you can only specify one uniform design speed from the station 0 going through up to the final station. So you can see right now I've adjusted the curve radius for a design speed of 70 kilometers per hour. And you can see the value is now meeting that minimum requirement based on the design standard I'm using. So it is now 185, not 150 something, which was violating the design requirement. So alternatively, that is in terms of horizontal alignment. You can also view the same for vertical. Just to now again look at your crests and the sags, plus the related grades in and the grades out for the same. And again, as you can see, in this case, they have been translated. The design speed has been translated into what we call the K value, as I illustrated in the part of the theoretical review. So you can see that if I provide a point of vertical intersection here, it will indicate to me the grade out and the grade in, both of which again are defined by the code of practice that you are using. So if there's any of them which violate the design speed that I had, again, you should be able to see that it will show you whether the violation is done or it is meeting the various design requirements based on the code of practice that you have selected. You can alternatively choose to show each of those points on the cross section to now get an understanding in terms of the various sectional slopes that you have used or the camber. And if you have correctly applied the super elevation, that's the rate of change from one point on the left or right hand side of the road, or taking it towards the center, just to enable the vehicles to counteract the effect of centrifugal force. So basically, that's just as an overview. I won't spend much time on it. So this is basically what I'm having, and you can easily see that even my geometry point along the road where there is a structure, like a bridge or a culvert or a tunnel, I easily see where each of them is. So that's the level of detail that you can be able to get from Infraworks in terms of just controlling your vertical geometry, horizontal geometry. That's like the sag, the curves, plus their corresponding crest as well. And also the precise point of intersection for your horizontal alignment, which I can easily again shift to be able to vary the size and the length of the curve that I want to have. Alternatively also, before you move further with your design, what Infraworks also allows you to do in terms of your preliminary design is to be able to optimize your design. You can perform optimization for your vertical geometry and horizontal geometry, just to be able to ensure that you achieve the most optimum cut and fill values. So to do that with Infraworks, you go into the roads asset and you look for the analysis part. And on the review and modify your roadway design, you should be able to select profile optimization or corridor optimization. And that's found on the now on my asset cards, which are found on my left hand side. You can be able to see that I'm having profile optimization plus corridor optimization. So like if I want to optimize my profile, so it's basically allowing you to get optimum cut and fill in terms of fixing for you your fixed PVIs along the road. So I can easily choose that. That's the road I've selected, and you can see again, the determining factor still is the design speed, which in this case I'm using 70 kilometers per hour. Means that if I was still again to increase the design speed, I may still require very high curve radius and a wider spacings of my points of vertical intersection. So there's still more settings that you can do, like choosing the PVIs to anchor, the maximum grade in and out that you want to use, the minimum PVI spacings. The quantities option, again, you can choose like what will be my borrow pits, what will be my waste pit along the corridor that I'm designing. You can go further and start specifying the construction rule. So like where there is a very deep curve, should it provide a bridge or a tunnel? So like in this case, I'm opting to use a bridge. The same also for construction and earthwork cost. You can go ahead and choose and specify that after having given me the approximate cut and fill volumes, if this is the unit rates, what the overall cost do I require to be able to implement that on site? So you can see I can be able to specify my unit price for excavation, loading, doing the mass haul, embankment if there is, the borrow pit and the waste pits, and even the precise number of each of them that you have specified. So with that, it is a cloud computing functionality within Infraworks. It will be able to upload your proposed geometry, that's the corridor, into the cloud, perform the analysis, and give you the results. So I will show you again in form of the results that you expect as an illustration. I'll switch my screen to show you. So it downloads in form of a PDF, and it gives you basically the PVIs that you have fixed. So this is a sample profile optimization report. It's just one I ran yesterday before this. So it gives you like if there's this structure along the road. So like where's the start of the bridge, where's the end of the bridge, which are the PVIs that you have fixed, the curve start, the curve end, the proposed waste and the borrow pits along the road geometry. And also, since you have defined the unit rates of doing your earthworks, it gives you the total projected costs. Also the linear unit for the road, the maximum grade, the minimum grade, and each of those parameters that I was defining. So from there, you can even be able to project the cost of doing one unit rate of the road from the assembly that you have specified. But more so also, it also gives you an overview in terms of the hauling scheme. Remember, we defined the whole parameters. So you can tell me maybe I require this number of movements for maybe for the material from borrow pit to the waste, and also from waste to maybe a specific location in terms of the earthworks that you're looking at. So this again will be able to advise you also in terms of the precise stations what are the expected amount of cut and fill as you move from start to the end of that particular road that you are trying to do its concept. So those are some of the level of the detail that you can achieve within Infraworks at the preliminary design stage. So after that, again, I will assume I'll share my next screen back into Infraworks to illustrate now, assuming that you have done all your related preliminary design parameters within Infraworks. So how do we move now that intended preliminary design into Civil 3D for our detailed design, where you can now have control in terms of our vertical profiles, where you can easily ensure that we will specify different design speeds and design criteria for specific component of the road. So to do that, you go into your settings tab within Infraworks, and we want to export it as an IMX file. But alternatively, you can just go into Civil 3D and choose to open the entire Infraworks model. Okay, so since I just want to do it fast, I won't open the entire model because that usually consumes some time. So I'll just say export IMX. So exporting IMX allows me to choose a very small portion of the model. So I'm only interested in the road corridor that I was working on. So I choose a polygon, just covering that small portion of the road which I'm interested in designing further within Civil 3D. Then I end it there. Most important also is to remember to always choose your coordinate system when moving from Civil 3D into Infraworks. It allows the data to be georeferenced. So then I'll export. I'll just click on export. So already I've done this before, so I won't again allow it to proceed because it may consume some 2 or 3 minutes. So I'll just cancel that. Then I will now move into Civil 3D to illustrate how we bring that concept, where you'll be able to see that the process of maybe importing your point files, the process of generating your surfaces and producing them further will automatically be done when you integrate Civil 3D and Infraworks. So the surface that you had created, both the proposed corridor surface and the existing topo surface will automatically be imported, plus the corresponding road, corridor, and furniture that you have within Civil 3D will automatically be taken into Civil 3D during that process of interoperating between Civil 3D and Infraworks. So I will switch now into Civil 3D to be able to illustrate again how you bring up that concept into Civil 3D. So I'm sharing Civil 3D screen now. So I'll just have to move away some of the points which I already did. Again, just help me save on time. Just a minute. My Civil 3D still saving because I already had something in the background to back me up. So I'll just move away from that. So that basically shows what I intend as the end product. So I will illustrate how to, so like to start from scratch. So, and of course, your work will be significantly reduced if you already have a very well-defined Civil 3D template. If you already have this template in place, starting your detailed design within Civil 3D from the data that you already processed within Infraworks become very, very easy. So I've started this for the demo start. So that's just basically showing the process from the start. But you should start by clicking on the application menu for Civil 3D and click new to enable you to start from the template. So basically template is defining your, maybe the drafting, then the CAD standard that you want to use within the Civil 3D. Things like maybe the labels, the profile, the alignment styles, and all those related styles that you want to use within Civil 3D. So I'm having a number of them here, but the one I intend to use is this one for the plan and profile. So you click to open to enable you to start the project from that particular template. So the template basically defines like what you already want to use within Civil 3D in terms of the alignment label styles, the alignment style, profile, the plot styles that you want to also use within that particular project that you are doing. So that's basically how you start. Then it opens up, then you save it. After that, you just go into your tabs and select Autodesk Infraworks tab. So there's Infraworks tab already present within Civil 3D to allow you exchange the data between Civil 3D and Infraworks. So now that we have the preliminary design within Infraworks and we have already exported it into IMX, what we now do within Civil 3D is to import that IMX file. Alternatively, you can open that entire model as I had said, but that usually consumes your time and it may bring in even some component of the model which you do not need to use within Civil 3D. So I said IMX allows you to only use the specific portion of the model that you are interested in. So again, you click on import IMX file. It takes a few seconds and it will bring you up the model within Civil 3D. So I've already done that again. And you can see also that my data is georeferenced. Alternatively, to illustrate how georeferenced is by setting the coordinate system of your model by going into the stats in the settings tab of the prospector tab, sorry, of the tool space, and you right click on the name of that drawing and say edit drawing settings, and you should be able to choose the specific coordinate system of your project. And again, this varies based on the location and the region that you are designing the project on. So then after that, now you can just proceed. I'll be able to see my data which have already been brought in during that process. And you realize that very many activities that you usually perform when you use Civil 3D from scratch, as I said, most of them already been done to you. So there should be the existing topo surface, the one which I have now selected. And if I go into the surface properties, I should be able to see, it tells me it is the existing ground and the specific surface style that I used as my default. The same also happens if I go also, there is the proposed corridor surface, which if I go to again properties there of the surface, it can show me very well it is my proposed ground surface. So the process of creating each of those one by one when you use Civil 3D from scratch is already been eliminated. The same also your various assemblies that you needed to configure to form the road corridor. The process of interoperating between Civil 3D and Infraworks already generates them for you. So your work only is now to ensure that the various camber or slopes for those assemblies are as required, the minimum thicknesses of the road assembly that you want to use, like maybe the riding surface for the road maybe should be 20 millimeters bitumen, or maybe the base should be maybe 300 millimeters. So each of those are now what you now need to ensure that they met the requirement as per the definition by the materials engineer. So then, after that now, the next thing is now to project this horizontal alignment and the corridor onto the profile view, which you quickly do that just by selecting the alignment itself and now say you want to generate its surface profile. And during the surface profile, you can see it gives me the name of the alignment. It is this alignment one. I didn't name it correctly from that movement. Then I'll just say draw it in profile view. And I will use everything as default because my template already has all those default settings, which allow me to easily do my work now. So you can see, I can now easily plot, and the same way I was seeing the profile views in Infraworks, I now look at it in a more detailed level within Civil 3D. So like you can see, this is the point where there is the bridge, but I can still project that bridge into the profile view to enable me understand exactly where's the start and end of the bridge. So I'll just say project an object, and I'll select that particular bridge here. I'll enter. Then I'll choose the settings again for projecting. I'll say do not add. It takes again some few minutes, some few seconds, and my bridge will be projected again on my profile view. Basically again showing me that this is where the bridge starts, this is where the bridge ends in terms of maybe the chain edges. Then I will automatically easily again apply the labels to that my profile. So I'll say right click and say edit labels, and I choose for it, I'll import a label set for it because again my template already has each of those defined. So I want to use this one. I'll click to apply that as the template for my labeling, and you can now see it starts telling me the various points of curvature, the point of tangency, the length of the curve, the K value in a very easier way to understand now as opposed to the way we are looking at it in Infraworks. So after having now projected it, I can now start looking at the specific design criteria for each of them. I will start with the design criteria for the horizontal alignment. So I'll come here and again select the geometry, and I'll go to the alignment property here. So in the alignment property, I'll go to the design criteria, and I will now specify to use criteria-based design. And it asks me I need to do that, so I'll just need to select that as a start. So this is the advantage which this has, as I said, that remember in Infraworks, you only specify an overall design speed or design criteria for the entire road. But within Civil 3 now, at detail level, you should be able to specify that this section, since the curves are very, very straight, I can use a very high design speed. But for these curving components or sections, let's lower the design speed based on the design criteria that you are using. So that's the next thing I now do. I start segregating or sectioning my road in terms of the different design criteria. So I will say that, let me just apply that. Then I want to check on my Civil 3D where the curve starts. So this curve here, it starts at a particular chain edge. It starts at chain edge 0 plus 600. So I will say that maybe from 0 plus 600 going through up to kilometer 1, I want to use a lower design speed compared to the entire component of the road. So I'll go back to the alignment and specify that. So I'll say from 0 to 600, I want it to be design speed. So I'll just click on that and say design speed. Sorry. So let me just specify 600. So then I specify design speed maybe 50. Then for the rest of it, from 600 going up to the end, I want it to be design speed 100 again. So you can see the design files are now here. So you can see, like right now, I'm still using ASHTO, but as I said, that you can customize each of these design standards to meet your local condition. So like the one here I'm having, which you have customized for our local condition here, that's the Kenya Road Design Manual. And it's the same one which I've opened here. So you just need to open it as a text file, and you can now start defining each of those parameters in terms of maybe the minimum radius speed for each of the curve radius, the grids in, the grids out, and the K values. So for example, the minimum radius table name for 2011 metric with a maximum super elevation of 10, you can see the curve radius varies from 15 going up to 110. No, sorry, the design speed varies from 15 going to up to 110, but the curve radius starts from 4, moving all through up to 454 when you use a design speed of 110. So basically, you're supposed to now read through your local design standard, whether you're using ASHTO, MRB, or your local design code of practice. You can now look at it and come and start customizing each of those design parameters within this text file and save it within the default file path, as you can see within this interface here. So that allows you to select the specific one that you want to use. So I can now switch back and use the KRDM, which is our local-based design standard here. Then I'll click to open it. So meaning that within that code of practice, the curve radius are already defined based on the specific design speed that you use. So I've seen that if I use a design speed of 100 kilometers per hour, you can see the curve radius becomes about 500. But if I use design speed of 50, the minimum curve radius almost goes to like 170 something. So that allows you now to start having each of those controlled parameters and checking for the tangency between each of those points as well, such that if there's a violation, it will be able to warn you as well. So if I click apply, you can be able to see there's already a warning here. So meaning that, that's what I was saying. Civil 3D now warns me that even though I've defined a design speed here, so you can see, tells me that the minimum radius is violated. The current radius is 157, but the minimum radius is 600 because of the value that I've specified. And the curve there, as you can see, is very, very sharp bend. So to eliminate that, you guys need to go again back into the criteria, and you can specify a lower value. So I'll say that this one starts from that, going through up to, it was 1 kilometer. Sorry, 600. Then this one, 1,000. Then I'll specify this maybe as 50 now, and specify this as 100 still. So that now allows me to be able to eliminate that problem in terms of the violation. And you can now see there is no warning because I've specified the design speed for that particular curve area, starting from the just before the curve start and just after the curve end to be less than 100. And therefore that allows me to accommodate that curve. So meaning that if designing and documenting that part, those are some of the design information that should be provided side by side with the operation of the road. That if you approach this particular chain edge, the design speed should be reduced from 100 to 50. So if you are approaching from the roundabout, going down straight at about 600 meters, you lower your speed just to ensure that you are safe not to be able to be toppled by the effect of centrifugal and centripetal force when negotiating that curve as well. So those are some of the details that you're able to achieve with Civil 3D. You can go further and apply the same also on your vertical geometry by even able to maybe increasing your curves, changing the position of your point of vertical intersection, the grades in, the grade out, and each of them. So each of those again are defined by the design criteria. So I'll go to the profile properties and select again to use design criteria. So right now the design criteria is turned off. I use that design criteria. I again choose the design standard that I want to use. I still want to use the KRDMB, and I click open, apply, and then I'll click OK. So be able to see if I go again now, you'll be able to see if there are any points along the curve which is violating the design speed. Again, I should be able to see a warning symbol, of which none, because I already adjusted them accordingly. So after that, we'll be able to produce the report. So if I want to produce that design verification criteria for my vertical curves, I'll go into the toolbox and be able to generate the results in terms of how did it ensure that each of those parameters are met. If the passing side distance is this value and the stopping side distance is this value, what does the code specify and what have I specified in my design? So I go into the alignment and I'll check on the alignment design criteria verification. So if I click on it, I just need to select for one curve. So there are a number of alignments. So I'll just uncheck these others to remain with the last one. Where the last one, to remain with the first one, sorry. So the first one is the alignment for the profile that for the road that I'm designing. So there's a number of them which are brought in from the process of importing from Infraworks to Civil 3D. So that is it. So I'll choose here where to save it. So I want to save it here as a text Word file. Then I'll choose it just default name. Then I'll come here and click create. So if I click create, it opens that report for me into what I can even be able to review and even edit by maybe adding my custom templates into it. So I'll just switch to show you that screen, how it looks like. So select new screen. It has opened it in Word. So this is it. So be able to see it now tells me this is the alignment design criteria verification report. And it gives me that for the first tangent, it starts at this particular chain edge. This is the length, and this is the design speed. But the next one is a curve. After the tangent is a curve, where the curve starts, the radius of the curve, and the design speed is 50. And the minimum radius is 100. So you can see it is clearing. The minimum curve radius required for a design speed of 50 is 100, meaning that the code clears that because it doesn't go or doesn't exceed the specification by the code. So basically, those are some of the kind of report that you can generate, and you can go to see that if there's a section which is violating that design criteria, you can see it also indicates that for you as well. So maybe I should go back into that alignment, identify this section, and ensure that the minimum curve radius at that particular point is greater than 600. So that's how good Civil 3D is in terms of generating your design reports as well. So I can even do the staking out for alignment report, the incremental change report for each of them, and even the setting out data for actual construction. So let me share the Civil 3D again so that I can finalize and show you the last bit. So the last bit, again, I'll assume that you have done that. So the last bit basically is to now like show how you can easily create your artworks. Like I want to easily create the volumes for cut and fill. So the first thing I need to do is to create what we call a sample line. So like specifying how many, what are the distances between my sections that I'm going to consider. Are they going to be 50 meters or 20 meters? So I'll say I want to do them at maybe 20 meters, 50 meters. So then I'll just click that OK. Then I'll specify that station range that I want to use. So I'll say I want to use station ranges for 20. So maybe let me use 50 chain edges 50 and 50 for each of them. Then I'll click OK. Then I'll enter. So that creates for me the sample lines. So basically sampling my corridor in terms of either 20 meters, 30 meters, 50 meters on the specific sections whose volumes you want to review. So then after that, I'll just go into the analysis part and do compute volume materials. And I can be able to see it automatically remembers that alignment which I selected. I'll click create. Then I will be able to choose my reference surfaces. So my existing ground is the existing ground. My datum is the proposed ground, because you have to calculate volumes with respect to existing and proposed. Then I'll click OK, and you're able to choose the specific volume calculation method that you want to use, whether prismoidal, average, or composite. And each of them varies based on the accuracy that they have. So then after that, I can pull out that report in form of a table, so total volume table. Then I can put it here. Then you'll be able to see it now gives me that between each point, these are the volumes that from chain edge 0 to chain edge 50, the cut volume is this, the fill volume is this. Okay, so that's, you can go further and even produce detailed materials for the different pavement that you're going to use as well for the pavement structure. So the last bit, I will illustrate how you can easily create your documentations. Like if I want to print my sheets, I'm running out of time, apologies. If you want to create your sheets, is to now just first do what we call, you go into the output tab and create the view frames. So the view frame basically specifying that if I'm having 2 kilometers long road, which specific section should fit on one sheet of paper, and what are the scales that I'm going to use to plot. So again, if you already have your layout template already set, that becomes very, very easy. So I will use everything again here as default, because I know I've already set them before. Then I'll click create view frames, and you're able to see it splits my road into those various components that can fit on one sheet. Then after that, I'll just click on create sheets. So create sheets now allows me to now put them on the specific paper sizes that, again, from the template that I'm using, will automatically allow me to do that as well. So I'll click, and then here under the profile views, I will do some small customization and I'll choose the specific profile to reference. So I still want to reference them as they were, that's the proposed plus the existing, but use a specific label style, which I wanted to use again this label style that I was using before. Then I'll just pick everything as default, because I'm very sure the data boxes is already set. The only thing I set here is again proposed against the design. Then I'll finish that. Then I'll come here and say create sheets. It asks me to save. Then I'll put my proposed sheets here. It again takes some few seconds, sorry. And I will be done with my sheets that I can now plot and share for approval purposes. So we'll be having our reports, as I'd shown, that you can generate the alignment design criteria verification report, and the quantities as you have also seen. And now I'm having my sheets. So if I go into the layout tabs, I should be able to see the sheets based on the naming convention that I selected in my template. Okay, so that's the last bit. So I think it's still reading it. So we should now come in, so can be able to see we are visibly, so basically they are defined by the template that I'm using. So you can still do the settings like maybe choosing the colors for your text and what have you, but if you already have the well-defined templates, as I was saying, each of those will automatically come in place without having to worry. So like I'm just showing how I can easily switch the color so that I'll be able to have them in white. So that's the process of now having the final output in terms of your road corridor, that's profile alignment, and the corresponding sheets and volumes that you would easily create. So that's the last bit, and I will not go further than that. So if there's still more interest or more detail, you can still reach out to me, then we organize a detailed live presentation and demonstration from your side. Zoe, back to you. If you have any questions, I can take questions at this point now.
Thank you, Elijah, for the informative presentation and demo. I'd like to open it up to our participants to use a Q&A. If you have any questions, please use the Q&A and we will answer them to our best ability. We have a question from Patrick. He's asking, is this program only for civil engineers?
Okay, for today it was meant only for civil engineering, because that's what was the focus for today, which was mainly meant for civil engineering with the focus on road design. But there are the same similar program are also being run by my colleagues who are focusing on the buildings and even manufacturing as well. So maybe we can just link up and share with you the details of how to get access to such similar program. But the one that I run as Elijah is purely on infrastructure. So switching in between roads and bridges.
Thank you. We have another question from Patushedzo. I think this question came about when you started doing the demo. Where do I get the background image that you are using?
So the background image you can either use within Civil 3D. There is if your data is georeferenced, you can use freely available Bing map within Civil 3D, and that is if you georeference by setting the coordinate system for your model. But with Infraworks, it is also freely available if you use Model Builder to build your model from scratch. But if you're using new, that is your own GIS and survey data, you may have a photogrammetry or an imagery from any other source, maybe from Esri's, GIS, or any other GIS platform that you may be using. But there's also a workflow of getting them from a Google Map. You can get the imagery from Google Map and use it, plus its corresponding DSM.
Thanks, Elijah. We don't have any more other questions from our participants. If you would like to view the webinar again, you may find the recording of the webinar on our IDA Technologies YouTube page, as well as other recorded webinars that we have done in the past. I'd like to thank the participants for joining us today. Thank you very much, and please enjoy your day further. Thank you, Elijah. Thank you.
Thank you, Zoe.